I will start recording. A stream saturated with DO has a flow of 1.2 meter cube per second. 1.2 meter cube per second. BOD of 4 milligram per liter. BOD of 4 milligram per liter. TB03. TB03. Erase the lines which you have drawn on the presentation. Erase the line, please. TB03. Who is TB03? Pratibha Birazdar. Pratibha Birazdar. Pratibha. गॉड, कनेक्ट करके कहा सो जाते हो क्या आप लोग? Okay, until she get wake up, you guys please write down problem. A stream saturated with DO has a flow of 1.2 meter cube per second, BOD of 4 milligram per liter, and rate constant 0.3 per day. It receives an effluent discharge of 0.25 meter cube per second, having BOD 20 milligram per liter, DO 5 milligram per liter, and rate constant 0.13 per day. The average velocity, write down please, there, keep on writing. I don't know where you are. You please copy it. कोई भी प्रतिभा का दोस्त होगा तो please call her and ask her to erase the lines which she has drawn on the board. Okay, over guys. Have you finished? Have you finished a write up something? It's too boring. Nobody's replying. Nobody is the friend of Pratibha, or she herself has left? TB03. I think so. She left. Okay, continue. Okay, a stream saturated with, once again, pay attention properly now. The problem is very easy. You need to understand the concept. Then it will be easy to solve. Okay, stream is saturated with DO. Has a flow of 1.2 meter cube per second. उसका discharge कितना है? 1.2 meter cube per second. And BOD of the same stream is 4 milligram per liter. Are you getting? BOD of stream is the 4 milligram per liter and the rate constant is 0.3 per day. Here only rate constant is written. Nothing is written. What type of rate constant is there? Whether deoxygenation rate constant or reoxygenation rate constant. That you should understand. How you can understand? The information is given with respect to stream, is it? If it is the information with respect to stream should have the reoxygenation constant. Because the stream is getting re-aerated and self-purified, and that is helping her to increase her BOD, increase the DO. So that if the information is given with respect to stream, that rate constant, you can assume that rate constant is nothing but the reoxygenation rate constant R. It receives an effluent discharge of 0.25 meter cube second. Okay, I will explain with a figure now. See here, I usually draw the same figure, same I will draw. Okay, see here, this is a stream. Okay, and the information about the stream is given as discharge, you can say Q. Discharge is 1.2 meter cube per second. Okay, and BOD is given 1 milligram per liter, and the rate constant, that is the reoxygenation rate constant. Reoxygenation graph is like this. So it's a rate constant is 0.3 per day. It receives an effluent. Abhi, so we are talking about the effluent. Wastewater is getting received into the stream. Now the quantity or the discharge of stream is 0.25 meter cube per second, having BOD is come. Okay, so whatever the characteristics now is being explained, it is about the wastewater. Okay, earlier about the stream. Now that BOD is 20 milligram per liter. Whatever the wastewater is there, BOD of that wastewater is 20 milligram per liter, and dissolved oxygen of that wastewater is 5 milligram per liter, and here also written rate constant. Now this information is about the wastewater. So what is this rate constant means? Definitely it is the deoxygenation rate constant K, and it is given 0.13 per day. The average velocity of flow of the stream is 0.18 meter per second. Average velocity. Okay, now when it is getting combined, its the average velocity is given combined in the sense this is the stream. Okay, this is a stream. It's a quantity Q, suppose, and this is a discharge or the wastewater, and its a quantity is the QE. Here we can say QS, and here we can say QE. So when it is combining, its velocity is 0.18 meter per second. Now calculate the dissolved oxygen deficit at 0.20 kilometer and 40 kilometer downstream. Okay, from downstream in the sense the point where you have deposited the sewage, क्या हुआ इसका line? The point where you have deposited the sewage from that spot at 20 kilometer downstream, what will be the dissolved oxygen level of that stream? And then again, after 40 kilometer of that specific spot, what will be the dissolved oxygen level of stream? Are you getting? So these two questions are being asked here to determine. Now, calculate the dissolved oxygen deficit at point 20 kilometer and 40 kilometer downstream. Assume that the temperature is 20 degrees Celsius throughout and BOD is measured at 5 days. So Y5 is given to you. Then take the saturation DO at 20 degrees Celsius. Take saturation DO at 20 degrees Celsius as 9.17 milligram per liter. So saturation level is also given to you. Okay. So all these things I have written separately as a given data on the next slide. But for your understanding, I have explained in the question itself. Is it? So those who have paid attention in the earlier lecture, they might have understood easily. And those who not, they might have also understood now after the explanation. Okay, what is the given data? DO saturation. The last line of this question is given to you. DO saturation, and that data is nothing but 9.17 milligram per liter. Now here I have written the QS, stream of flow, means stream flow, whatever the stream or the river is there, its a discharge is 1.2 meter cube per second is given. Then YS, intentionally for yes, I have given the dollar sign for avoiding the confusion. Sometimes many of the time we have to use the 5 as Y5, Q5, DO5 may be there. So that's why I have intentionally used the dollar sign for the yes to mention the yes. So it is the YS, BOD of a stream, and it is given to you 4 milligram per liter. Then rate constant R is given to you. Rate constant R is given to you 0.3, that is reoxygenation rate constant 0.3 per day, and the discharge of effluent is given to you 0.25 meter cube per second. Then YE, that is the effluent of BOD. The BOD of effluent, it is given 20 milligram per liter. Then dissolved oxygen of the effluent is given to you 5 milligram per liter. Then deoxygenation rate constant K is given to you 0.13 per day, and the average velocity V is 0.18 meter per second. And what is being asked to determine is the dissolved oxygen deficit at the downstream after 20 kilometer distance and after 40 kilometer distance. Okay, at these two specific points, you can determine the dissolved oxygen deficit. Then you can see here, now we will solve, we need to find out the first bubble. We know the individual characteristics of effluent, individual characteristics of the stream. Now we need to find out the mixed characteristics. Then we can determine, because that wastewater is mixing into the stream, then the self-purification and deoxygenation, these activities are predicting the dissolved oxygen SAT curve. Are you getting? After mixing in this, sorry, I will take a bigger side. Okay, after mixing that sewage into the stream, okay, it is getting together and then it is flowing. So that effluent quantity is deteriorating the DO level, and that stream's self-purification activities are increasing the DO level. So these two activities are determining the oxygen SAT curve. And here in this example, you are supposed to find out after this at 20 kilometer, what is the level of dissolved oxygen, and at 40 kilometer, what is the level of dissolved oxygen. Means during this passage, it is getting mixed. Two quantity of water is getting mixed. So you should find out the parameters or the characteristics of the mixed quantity of water. So first of all, we will find out the parameters of the mixed quantity. So Y5 notation, we know that we are using that Y5 since long time for the BOD mix. So Y5 is equal to, I have written the equation here, that is QS into YS plus QE into YE upon QS plus QE. With the help of this equation, you can determine the BOD of mixed quantity. Is it? QS is nothing but discharge of stream, QE is nothing but discharge of effluent, then YS is the BOD of stream, YE is the discharge, BOD of effluent. Okay, now you can put the value of these QS, QS, YS, QE, YE, QS and QE, and you can determine Y5. Okay, so here it is very simple. 1.2 is the QS you have written, and there is also no need to go for the change in units. You can see here QE is given to you in a meter cube per second. So QS is also given to you in a meter cube per second. YS is given to you in a 4 milligram per liter. Then YE is also given to you milligram per liter. Is it? So simply you can find out the Y5 with this equation. So I have determined here it is 6.759 milligram per liter as the Y5. Getting? Then now you can determine Y5. Yeah, one more equation. Which equation? Can somebody tell me? Which is this equation? Which equation I have written here? Okay, until you people don't tell me, I will not go ahead. Recently, I spoke before this lecture, in the last session of this lecture. What is this? Which equation is this? Write down in a chat box at least. In first chapter, we have studied this equation. We have derived this equation in a chapter number 1. Fast. Okay, someone has written. Okay, it is a BOD formulation, first stage BOD formulation equation. Is it? So that we have studied in a chapter number 1. First stage BOD formulation, that is BOD is equal to L naught into bracket 1 minus 10 raised to minus KT. BOD usually it is taken at 5 day at 20 degrees Celsius. So we have given the notation for that Y5. So that Y5 is equal to L naught into bracket 1 minus 10 raised to minus KT, where L naught is the amount of BOD present at the start. Okay, initial amount of, is it? So that equation, Y5 here we have determined 6.75, and from that you can determine L naught, amount of organic matter. Amount of L naught is the amount of organic matter present in a sewage at the initial stage. So L naught you can determine with the help of this equation. That is Y5 is equal to L naught into bracket 1 minus 10 raised to minus KT. I hope you have copied this slide. If not, I will give you 1 minute. You please copy. Then we'll go to the next. Have you done? Shall we go to the next point? Someone has written in a chat box. Let me see. Sonali Patel, Madam, L naught is equal to 8.708 milligram per liter, and what I have determined, L naught is equal to 8.8, yeah, 87 milligram per liter. Let me check. Let me calculate. Maybe my calculation is wrong. एक second na. Let me check my calculations. Wi-Fi is equal to 6.759 and K is given 0.13 and T, small t, we have taken 5. Why? Because it is the 5th day of BOD. So this T becomes a 5. You should understand what I have written. Okay, then I will calculate L naught is equal to this 6.759 and so on. 3. Yeah, it is 8.71. My answer is 8.71. Sonali Patil, what is your answer? 8.708. Yes, we can write 8.71. Sorry. Please, all are requested to correct this answer. I have written a wrong calculation here. The answer is good. 8.71 milligram per liter. Correct yourself, please, everybody. Thank you, Sonali. 8.71. Shall we go to the next one? Yeah. Now we have determined the value for L naught. Then we'll go to the next. Now DO saturation. We have that value of DO saturation is not given. We can take this 9.17 milligram per liter. Now remember one thing here. If DO saturation value is not given to you in the example, that time also you can take it 9.17 because I have told you the different range of dissolved oxygen level with respect to temperature. And for 20 degrees Celsius, usually we determine the BOD at 20 degrees Celsius. So at 20 degrees Celsius, the dissolved oxygen level of saturated level of dissolved oxygen at a standard condition in the river is usually 9.17 milligram per liter. So you can remember this figure and you can take if it is not mentioned in the example. Okay. Then DO of the effluent, it is given 5 milligram per liter. Am I correct? Then you can find out the way you determine the Y mix, that is BOD mix, you can find out the DO mix. Same way you can follow to determine, that is DOS into QS plus DOE into QE upon QS plus QE. Is it? So DOS is given to you. The DOS is nothing but the saturation level of dissolved oxygen. It is 9.17 and QS is the quantity of stream is 1.2 meter cube per second. Then DOE is a 5 and QE is 0.25. So you can check the answer. Though I have written 8.45 milligram per liter for the DO mix, you can check the answer, please. Then I will explain the further part. That is initial dissolved oxygen deficit D naught is equal to 9.17 minus 8.45, that is the dissolved oxygen of the mixed liquid, stream and effluent. So dissolved oxygen deficit D naught will come 0.72. So that equation, that formula we have discussed in the earlier lecture. Dissolved oxygen deficit is equal to saturated level of dissolved oxygen minus actual level of dissolved oxygen. Actual level of dissolved oxygen is the 8.45 and saturated level of dissolved oxygen is 9.17. So dissolved oxygen diffusion will be 0.72 milligram per liter. Okay, so copy this. So example is very simple. Only you need to understand the concept and terminologies. Then you can easily sort it out. Usually this example comes for the 6 marks or 5 marks sometimes. 100% this type of examples are there in the section 2 of environment 2. Okay, is the answer correct? The DO mix? Is the answer correct? Thank you. Pula also had given some answer. Yeah. Thank you, Priyanka Pula. Thank you, Sonali Patil. Okay, shall we go to the next point? Okay, now see here. Who is there? Sonali Patil again. Okay, thank you. Okay, now we came to the actual question. What is the actual question to you? To determine or to calculate the dissolved oxygen deficit at 20 kilometer downstream and 40 kilometer downstream. So first of all, we will determine dissolved oxygen deficit at 0.20 kilometer downstream. Downstream in the sense from the point where you have added the sewage. Okay, 20 kilometer downstream. So we know the equation to determine the time is equal to distance upon time t, small t is the time, is equal to distance upon velocity. What is the distance? 20 kilometer. Okay, 20 kilometer and velocity is 0.18 meter per second. Okay, so directly I have written here in a converted form. In a converted form, I have written here. Distance is 20 kilometer. I have converted by multiplying 1000 here in a meter. And velocity is given to you 0.18 meter per second. Okay, so meter will remain as a meter, and per second I have converted it into per day by multiplying the factor 60 into 60 into 24. Is it? Am I right or wrong? If it is wrong, please suggest me the correct answer. And determine the time t is equal to 1.286 per day. Sorry, days. 1.286 days. Please check the answer. Then I will explain the further term. Yes, correct answer. 1.286 days. Okay, thank you very much. Now, I will explain the further part now. Using Streeter-Phelps equation. What is the Streeter-Phelps equation? We have determined the Stater-Phelps equation by superimposing the rate of deoxygenation and rate of reoxygenation curves. Is it? d dt upon dt is equal to f d dt upon dt is equal to k dash into L naught minus R dash into dt. And then we superimpose that equation, and then we got the equation. I cannot explain that equation. Is it? So that equation further we have sorted first order first degree differential equation we have determined, and then we have solved that equation and we determined the equation which is nothing but the Stater-Phelps equation, that is dt is equal to k into L naught upon R minus k into 10 raised to minus k into t minus 10 raised to minus R into t plus d naught into 10 raised to minus RT. Sometimes in the example, they might have explained, mentioned that rate of deoxygenation to the base E and rate of reoxygenation to the base E. In that case, you should take this equation in the form of base to the E. So it was not mentioned, so we have taken in the form of base to the 10 form. Is it? So here in the form of base to the 10, I have written the equation. Now dt is equal to k dash k into L naught. K is given to you 0.13. Then L naught we have determined 8.71. Then R is given to you rate of reoxygenation 0.3 minus rate of deoxygenation 0.13. 10 raised to minus k is the 0.13 into t, small t. What is that time? At 20 kilometer, to reach the mixed sewage at 20 kilometer, how much time is going to be required? This much. It is 1.286 days are required to reach up to the 20 kilometer distance. Is it? So that time we have taken dt. So we have taken d 1.286. So here also t you should take 1.286. And then minus 10 raised to minus RT. 10 raised to minus R, value of R is the 0.3 into time is same 1.286 plus D naught. It is the initial dissolved oxygen deficient. Okay, so that also we have determined from the by using the equation D naught is equal to saturated dissolved oxygen level minus actual dissolved oxygen level of stream, and that we have calculated 0.72 into 10 raised to minus 0.3 into 1.286 is the time. Okay, now from that you can determine D at 1.286 time, that is nothing but at the distance 20 kilometer. What is to be determined? Dissolved oxygen deficient at this 20 kilometer means at this time 1.286, and that you can determine. You can write down this answer or you can calculate and cross check my answer. I hope you are understanding. If not, anyone can ask question.